Hi there. So today I'm going to show you how to get an equation that will help you get the electric field of a cylinder. So let's go over some of the labeling and the variables and stuff. So let's start with this picture here. As you can see, we have a cylinder with some green arrows and a couple of red marks. So let's start with this guy here, the lambda. So the lambda represents the charge per unit length. And then let's move on to the E with the green arrows. Those represent the electric field. For A, these A's with the arrows on them, the A's represent the surface area, and the red arrows that are with them represent the ways that those surface areas are facing and pointing or facing. The Y here, that represents the distance from the center to the surface of the cylinder, aka the radius. The X is simply just the length of the cylinder. The Q, which is for this guy over here, that's the total charge enclosed. And then the epsilon naught, of course, is just a constant. So this is our Gauss law equation. So it's the integral of E, our electric field, times A, the surface area, equals Q, our total charge enclosed, over our epsilon naught. So let's move on. So the first thing we have to do is, well, let's first point out the cylinder. So the cylinder, I like to think of it as in two parts here. The shaft and the two end sides, or the end points. So because of this, it's going to have different surface areas here and here. So because of that, we have to separate this equation. So let's do that first. So the integral, so the first one we're going to do for the shaft, the main part, so that's going to be the integral of E times A. We're going to add that to the other part, which is going to be for the end pieces of the cylinder. So that is simply just going to also be the integral of E times A, and of course that whole part is just going to equal Q over epsilon naught. So now that we got that, what's our next step? Well, let's try putting some cosines in there. So let's see here. Let's do integral of E times A. Again, this is for the shaft part, times the cosine. So what do we use as our angle for the cosine? Well, so as I mentioned before, these surface areas have arrows pointing out, which represents what direction they are facing. Basically, we use the electric field lines and these arrows for the way that the surface area is pointing to just kind of represent the angle that's between them. So these are parallel, right? So that cosine is just going to be 0 degrees. All right, plus for the endpoints now. Integral of E times A times cosine. Now, since these areas are facing this way and are going this way, and since it's not parallel with the electric field lines. So, but I do know what it is. It's perfectly 90 degrees. See how this is going up and that's perfectly going that way? That's obviously going to be 90 degrees. So cosine of 90 degrees. Now, from simple math, we know that this cosine 0, that equals 1. And we know that this cosine 90, that's going to equal 0. So let's plug that in. What's E times A times what is now essentially going to be 1. E times A. Integral of E times A. And that. What's E times A times what is now going to be 0? It's 0, right? Yeah, it's 0. Because again, this cosine 0, that equals 1. So when I say, what is, you know what I mean. So cosine 90, again, 0. So now we have this 0 here. All right, let's move on. This E. So we do know that the distance from the center to the surface is going to be the same everywhere around this cylinder, right? So we know that the magnitude for each field, electric field line, is just going to be the same. They're all going to be the same. So because of that, we can move this. Oh wait, almost forgot. Also kind of forgot up here. Sorry about that. Just want to add that back in so that we know that that's what it's going to equal to for now. So let's move this E out here. F. So E times the integral of A, right? We don't need that 0, equals Q over epsilon naught. All right, now that we've taken care of that, let's look at the Q over epsilon naught. So we know that Q is our total charge enclosed. Well, believe it or not, if we multiply our charge per unit length times our length of the cylinder, we can actually get the total charge enclosed. So, saying that, we now know that Q basically equals lambda x, because again, if you multiply charge per unit length times the length, you get the total charge enclosed. So, knowing that, we can actually replace this Q. So we can do this now. E times the integral of A equals lambda x over epsilon naught. All right. Now, let's talk about the integral A. So that basically wants us to find the entire surface area, which of the that basically equals the entire surface area of the cylinder. So knowing that, how do we find surface area of a cylinder? How do we do that? Well, we do that by simply multiplying 2 pi times the radius of the cylinder times the radius of the cylinder times the length of the cylinder. So we put this where that integral A is, but instead of putting R and L, we'll put Y and X, because that's how we have it labeled here. So E times 2 pi times Y times X, which equals the lambda X over epsilon 0. All right, we're almost there. Now, from here we can just do some simple algebra to get E of the electric field, E, by itself. So let's do that real quick. How do we do that? Well, let's get rid of this entire thing, 2 pi times Y times X. How do we get rid of that? We can simply multiply this side by 2 pi times Y times X. All right, and now we can actually do that over here. Do the same thing over here. 1 over 2 pi times Y times X. All right, this is gone, that's gone. E's by itself now, that's great. Now, since we have this on this side now, we can actually get rid of these X's, because it's just simple, it's multiplication for a fraction. So, we're just canceling out these X's now. So let's get rid of this X, let's get rid of that X. Now we have E, the electric field, equals lambda over epsilon naught times 1 over 2 pi times Y. That's basically it. And since it is in the radial direction, the only thing we gotta add now is just that Y hat. And that is the equation to find the electric field of a cylinder. Thank you.